Hello. Now we are going to demonstrate our waveguide related practicals. Uh, this is actually the tutorial related with EM Tempo, lesson number 8, modeling of rectangular waveguide structures. We are referring this tutorial for the demonstration of EM Cube software, specifically EM Tempo model for the waveguide modes distribution. Here we are considering WR650 rectangular waveguide. Dimension is 16.51 into B is equal to 8.255 centimeter. And first we calculate the TE10 mode by is equal to C into pi upon 2 pi A. So 3 into 10 raised to 8 divided by the broader dimension we have to pick. This dimension should be in the meter into 2. So we are getting the cutoff frequency for the TE10 mode. So TE01 mode, basically we are getting the frequency 3 into 10 raised to 8 into 2 into smaller dimension, that is 8.255 mm. So these dimensions we are getting this frequency, and if 1 dominant mode, that is C by 2 pi upon A dimension, broader dimension upon this is the smaller dimension. So we are getting almost 2 gigahertz for the TE11. Now to do this, we have to open our EMCube software. So this is the open EMCube software. Here is the Terrano model. The next model is Tempo. You have to click on the Tempo model. First set the centimeter millimeter dimension unit. So I am taking centimeter. Click OK. Set the frequency 1 gigahertz is OK for me. Click OK. Then go to these CAD primitives files. Click on the CAD primitives files. Right click here. So just by using mouse you can first click here, then take the height, click here. This is our waveguide, and here you can put the dimension, that is a 16.51 centimeter by 8.255 centimeter by 100. This wavelength we are taking, we have to right now you can observe this is closed. Now you have to open the cap upper side, click OK. So now your waveguide is ready, because here you can observe this is the button to rotate it like this way. So you can see this is the now the total waveguide is now hollow. So after this we have to excite with the waveguide source. Here we are putting our waveguide source that bottom side, basically when we place it 6.24. So here you can see the yellow color lines are there, which indicates about your waveguide, and this is the direction of incident direction. So this is waveguide is throwing this power to this way. So here is you have to adjust the mode TE10. Now I adjusted mode TE10 and click on OK button. Go to the observation site where the field sensors, you have to keep the field sensors in the Z direction on 50. So one sensor is created here, another sensor, insert observers 100 exactly at the end of the waveguide. At the same times we have to give the observation at Y direction, means half cut of this the border side. Insert one more at X direction. Okay, so this is done. Now go for the running test. Yes, so here basically the idea is to this is the FDTD domain where we assign our waveguide PEC. Then this is called as a physical structure. The second is a computational domain. FDTD is automatically adjusts everything, boundary condition. You can raise a boundary condition, but it consumes some kind of memory and time for the simulation. Then the discretization, this is actually the mesh setting we called as Here the mesh setting is done, that is also automatically defined. The sowers is there, lump sowers, ideal sowers, lump load conditions you can apply different load condition, reactive load conditions. Then the waveguide source is there. In the waveguide source you can excite the source on different modes. So basically, then plane wave excitation, Gaussian and Hessian surface excitation, and afterwards the observation. You can observe a field probe, means you can put a probe at some particular location xyz, and you can see this effect of the radiation or the near field on some particular point. Then the field sensor means they are taking actually the surface current or the patterns. They are helpful for the pattern analysis. Then the far field pattern is related with the antenna radiation patterns. Then hygiene surface are related again with the radiation patterns. Then port definitions. Port definitions means we are applying our port is a 50 ohms. We are declaring that yes, our port is 50 ohms, like this. Then periodic characteristic is only for frequency selective surfaces, metamaterial based surfaces. And last is data manager. So data manager shows us the reading in the 2D Cartesian. Now he is doing the convergence, and this now it's simulated. Close. So this is the first fellow where with the 50 we are taking, let's say exactly at the half side. We go there, we increase the things. Okay, now you can visualize this white color comes in middle side, and then the yellow color. Okay, I keep here mouse and I take some pen. So here you can see this area. In this area, a white color means maximum energy is concentrated, because this is the maximum index of the legend. It shows on the by using white color slowly, then yellow color, then there is a reddish, then the blue and the black. Black means no energy. After waveguide there is no energy. Around the waveguides everywhere zero energy is there, or very small energy there. The middle side the energy is high, and then gradually the energy is going to be low. And the same things actually observed in our books, where the generally keep, okay, I have to go to, okay, so so if we go to in this area, the same things we going to observe that here also the same energy, basically you can find out this in this area the high energy is there. Gradually the energy is looking low and low in TE10 mode. TE10 mode is the high power present in the 10 mean the segment, whereas the 20, if it is tell, this is the broader area of waveguide, a smaller area of waveguide. Then this is the again 20 means it is repeated the patterns for the two times, patterns is going to be repeated. 30 means the three times the pattern is going to be repeated. When we say 01, 01 means the instead of going the E field in the straight direction perpendicular to Z, this Z perpendicular is now shifted towards the smaller broadside. So this comes like this way. If it is 01, 02 means again two times it is comes in the waveguide. So same things, the same things we are going to observe in our software. Here also the things and the same patches are there. Even we can observe these things in the after. So we will go and see the next look. And here we just rotate it. Okay, otherwise we can adjust it here also. You can see this is the pattern which comes in the pictures. We will go this now. Slowly we have to take the middle. Okay. Now see, this is these are white colors, means the high energy is there. Then again energy drops, again energy drops and comes. So by using this side view we can visualize the pattern, basically how much the wavelengths are going to be occupied in the 100 millimeter. Even in the side view we can observe the other types of patterns. Now we are going to observe. Okay, the triplets. Yes. This is magnetic and this is electric. So this is the patterns where we can is observe also in the books. So the similar patterns from the side angles you can observe on the waveguide. So in this way we are actually varying the T10 or other modes, excite the modes and see the pattern. Thank you.